All right, today we're going to do something a little different. We are going to take a real AQA GCSE Chemistry exam question and just pull it apart, piece by piece, using the official mark scheme. So, what's the goal here? It's to see exactly how you win those marks and, more importantly, how you can start to think like an examiner to make sure you get every single one. Okay, let's get into it.
So, we're jumping straight in. No messing around. This is question 1 from the higher tier paper. You can think of this as a peek behind the curtain. We're not just looking for the answers, we're trying to understand why they're the answers, according to the people who write the exams.
So the question kicks off with the periodic table, which, is pretty much the heart of chemistry. These first two parts are all about using what you know about its structure and the properties of the elements inside it.
Right. Question 01.1. We've got 3 clues here for element Q. It's a dull solid, it has a really low melting point, just 44 degrees, and, this is a big one, it doesn't conduct electricity. Now, what do those properties scream out to you? They're the absolute classic calling cards of a non-metal.
And boom, the mark scheme confirms it. The answer is D. If you look at this simplified periodic table, section D is over on the right-hand side, and that's exactly where you find the non-metals. Simple as that. 1 mark in the bag. Let's move on to the next part. Now we're looking at element R. The clue this time is that it can form ions with different charges, a 2+ ion and a 3+ ion. This ability to have a variable charge, well, that's a very specific trait. The real question is, which group of elements is famous for doing this?
And the mark scheme tells us the answer is B. But why? Well, because section B represents the transition metals. And one of the key properties you absolutely need to remember about transition metals is that they can form ions with different charges. So that clue points you straight to section B. That's another mark sorted.
Okay, now the paper wants us to do a bit of a comparison. This next question is for 2 marks, and it's asking for physical differences between the alkali metals in group 1 and those transition metals we just identified. Now, what's really useful here is that this slide shows every single possible correct answer, word for word from the mark scheme. To get the full 2 marks, you just need to state any 2 differences when you compare group 1 to the transition metals. So for instance, you could say group 1 metals have lower melting points and they're softer. The mark scheme is also fine with the reverse, saying transition metals have higher melting points and are stronger. As long as you give 2 clear correct points, you've got the marks.
Okay, time for a more hands-on task. Question 01.4 takes us away from properties and into atomic structure. It's asking us to draw the electron configuration for an aluminium atom.
So on the left, you've got the blank diagram from the exam paper, and on the right, the perfectly completed one from the mark scheme. So how do you figure this out? You go to your periodic table. Aluminium is in group 13, period 3. Its atomic number is 13, which means it has 13 protons and 13 electrons. So the electronic structure is going to be 2 electrons in that first shell, 8 in the second, and then the last 3 go in the outer shell. It's a really clear example of how to turn data from the periodic table into a diagram and grab yourself a pretty easy mark. Right, let's see where they take this next. The following questions are all about our fundamental understanding of metals, what actually makes them conduct electricity, and how do they bond with nonmetals.
This is a classic 3-mark question. Describe how metals conduct electricity. But wait, look really closely at that last sentence. Answer in terms of electrons. This is a huge clue from the examiner. It's basically them holding up a giant sign telling you exactly what your answer needs to be about to get any marks at all.
So, how do you structure this for 3 marks? Here's the play-by-play from the mark scheme. Mark number 1, you get this for saying that metals have delocalized or free electrons. Mark number 2, for explaining that these electrons are what carry an electrical charge. And the 3rd mark, for stating that these electrons can actually move through the whole structure. See, each point is a logical step, and using that specific language, delocalized electrons, that's what they're looking for.
All right, next up is a super quick 1-marker. Question 01.6 asks you to name the type of bonding in compounds formed between metals and nonmetals. The answer is simply ionic. It's a straight-up recall question, just checking you know your basic bonding types.
And here we are, the final part of question 1. This is the big one. It's worth 4 marks, and it's asking us to describe a specific reaction, pulling together everything we've touched on, atoms, electrons, and bonding.
So, the question is, what happens when magnesium reacts with oxygen? And, you guessed it, just like before, the examiner gives us a massive hint. You should refer to electrons in your answer. So, we know we have to talk about electron transfer.
And here it is. the perfect 4-mark answer, all broken down by the mark scheme. First mark, for stating that the magnesium atom loses electrons. Second mark, for saying that the oxygen atom gains those electrons. Third mark, you gotta be specific, state that 2 electrons are transferred. And the fourth and final mark, you explain what happens as a result. Magnesium ions and oxide ions are formed. Each point is a clear step in how that ionic bond is created.
So, we've just deconstructed an entire 13-mark question. But the real lesson here, the thing to really take away, isn't just about metals and bonding. It's about developing an exam technique. It's about learning to think like the person who's going to be marking your paper.
So, let's nail down the key takeaways from all this. First, use precise scientific language. Saying delocalized electrons is always going to be better than something vague like sea of electrons. Second, read the question properly and answer exactly what it's asking for. Third, use the number of marks as your guide for how much detail to write. A 3-mark question needs 3 clear points. And finally, always hunt for those keywords and instructions that are designed to help you get to the right answer.
We've seen how a really complex-looking question is actually just a series of smaller logical steps. And by understanding how the mark scheme works, you're not just learning chemistry, you're learning the language of exams. So my final question to you is this: what was the most useful tip you picked up today that you think you can use in your next exam?